Today, we're going to try to confuse the mind a bit and disrupt the concept that the speed of light is unsurpassable. We're going to look at some phenomena where reactions can be just as fast, or even faster, with respect to time and space. Could this be true, or am I a victim of the Dunning-Kruger effect? You've probably heard that when two quantum particles are entangled, their properties remain correlated no matter how far apart they are. That's strange, because it suggests some kind of connection that doesn't care about space or time. But here's the important part. No information actually travels between the particles faster than light. What we observe are correlations between measurement outcomes. Not a signal, not motion. This only happens in the quantum world. For macroscopic objects like stars or galaxies, space and time behave as expected. At the quantum level, though, particles exist in a superposition. They can be in multiple states at once. When measured, this superposition collapses into a definite outcome. If particles are entangled, the collapse appears coordinated, even across large distances. But again, that doesn't mean anything is traveling faster than light. It's a statistical relationship, not a cause and effect signal. So, is space and time just an illusion? Probably not. But do quantum systems behave in ways that challenge our classical intuition? Absolutely. Let's imagine something trying to reach the speed of light. If an object with mass tried that, time for it, from our point of view, would slow down more and more, theoretically stopping at light speed. But in reality, nothing with mass can get there, because it would require infinite energy. That is why we use c as a universal constant. The speed limit of the universe, 299,792,458 ms. If something were to break that limit, our known laws of physics would no longer apply. Still, there's one thing that seems to jump across space instantly: a thought. Of course, this is EDT faster than light travel in a physical sense, but our consciousness can leap conceptually across the universe in an instant. This poetic metaphor raises an interesting question. What role does the observer, our consciousness, play in shaping reality? In the early 1900s, the Copenhagen interpretation of quantum mechanics suggested that observation causes the collapse of a quantum wave function. This doesn't mean thoughts directly change reality, but it does raise profound questions about the connection between measurement, knowledge, and the physical world. Some thinkers have taken this further. Biocentrism, a philosophical theory by Robert Lanza, proposes that life and consciousness are fundamental to the structure of the universe, not just accidental byproducts. It suggests that the universe arises in part through observation. While this is not a mainstream scientific theory, it's a fascinating perspective that blends physics with philosophy. In the early 2000s, a Japanese researcher named Masaru Emoto claimed that thoughts and intentions could influence water crystal formation. However, his work has been widely criticized for lacking scientific rigor and reproducibility, and is not accepted as evidence in mainstream science. Still, the idea that consciousness may interact with matter at some level continues to intrigue both scientists and mystics. Back to physics. Balance is everywhere. Everything in the universe is in motion, even what appears still. Atoms vibrate, energy flows, and even space itself expands. Objects that appear solid and unmoving, like a rock, are just systems in dynamic balance at the atomic level. Balance creates the illusion of stillness. Take the expanding universe. It seems like space is stretching outward faster and faster, yet this is balanced by dark energy, a mysterious force that keeps everything from collapsing. In other words, motion and stillness are two sides of the same coin. Activity and passivity are in constant interplay. Imagine a photon flying through space. It disturbs its surroundings by creating a wave of light, but the moment it passes, the environment returns to its prior state. This rapid rebalancing happens at the speed of light. Not faster, but still astonishingly fast. The key insight is this: we are not separate from the universe. We are part of its constant motion and transformation. Our thoughts may not break the speed of light, but they connect us to each other and to the universe in profound ways. So next time you wonder how fast something can be, don't just think in terms of motion, think in terms of awareness. Because in many ways, the most powerful force in the universe is the one asking the question. Thank you for watching this video. If you liked it, please subscribe and share it with your friends.